Alright, so today it's day 60. I only did one lead code problem. It was this one, the time-based key value store. And we are at 26 out of 150 days. And let's go and do it again. So in this problem, we're given, here is a bit different than the one in lead code, but I believe that it's essentially the same. We're gonna use a class which is called timeMap, and it's gonna have like two methods, which is the set and the get, and we're gonna like input like some values followed by a timestamp. A key that can have like a value and a timestamp. And we're gonna also we want to be able to make queries based on a key and to return like the corresponding timestamp. But here, like, the catch is that essentially the timestamp that we're gonna query could not be exactly the one that it saved. So we want to return the closest one to the left. I think it's I'm gonna show maybe like a quick example just to illustrate the point. But we could have we're gonna have like you can think about it as a dictionary. We're gonna have like a key one, and this key is gonna be append like to a list, and this list is gonna have like a value, and it's gonna have like a timestamp. So it's gonna be 1, and then we can append to the first key, which is this one, another value, and add also like a timestamp, which could be like this one. And then for another key, we can have like other value, or even the same value, whatever, and a different timestamp, and so on, right? And the main intuition, where like everything relies on, it's like in this list, because this list, you can see like the second element, which is gonna be an assorted non-decreasing array. So it's gonna be, I don't know, like could have like these values, and if you're giving, I don't know, like the number 4, you're gonna return the value associated with the timestamp, with this timestamp. But if you're given like the number 5, you have to return, given that in this array the 5 doesn't exist, you're gonna return the 4. And that's essentially it. That's it. And to do it, first we gotta make the set value. So given that we are working with we're gonna make a dictionary out of it. We can add it as a attribute. So we can say something like self store, and store is gonna be like the dictionary, default dictionary, and it's gonna be a dictionary of lists where each element in the list is gonna be a tuple of value and timestamp. So when we add values, we can say just like self store of key. It's gonna add to the list the value, the tuple, which is gonna be value timestamp. And for the get method, essentially what we're gonna do is over this array, over this array of these elements, we want to compute like the lower bound, like the left bound. So it's basically for a given target, we want to find the first value to the left that it's equal or left than t. So we gotta search like from the right to the left, basically. Yep. So we can do like, we can set first a left and a right pointer as always. And okay, first we're gonna get the values. So it's gonna be like, I don't know, like array, it's equal to self.store key. So basically, if somebody makes a query, we're gonna ask ourselves to which array corresponds, because for every key we have an array. So we locate the array, which is gonna be this one. First, we're gonna ask if the array is empty. because if the array is empty, if not array, yeah, if the array is empty, then we're gonna return like empty. The value is gonna be empty. Otherwise, we're gonna do the binary search, and the binary search is gonna be over the length of array, and we're gonna do while left less than right. We compute the middle as always, and the value it's gonna be array mid. But the thing here is that we know that each element in array it's a tuple, and we are making the search over the second element. So we're gonna do this, and now we can check if the value is less or equal than the target, which in this case it's called timestamp. And if it's equal, then if it's less or equal than timestamp, so basically if we have like this, and the middle is this one, this is gonna be left, this is gonna be right, this is gonna be the middle, and if the target is here, then basically implies that we need to move right to where middle is now. So we're gonna say right is equal to mid. Otherwise, by the same logic, we are gonna move left, right? We're gonna move left, because if this is the case, we're gonna move this one, and we can move this one directly to this one, to plus 1. And given that we are initializing the array here in this position, because we are not doing length of arrays minus 1, so when we do the mid, we are updating like to the right one. Also here we are not entering, so basically at the end left and right are going to be equal, the same as middle. Yeah, so we have to take into account this one and not this one. And once this is over, we can return, given what I've explained, that is like to the right one. We need to return one to the left. So we have to say, I mean, we can pick whatever. Let's pick L minus 1, and we're going to return L minus 1. I mean, not L minus 1. The value corresponding, yeah, because it's a tuple, the value corresponding to this timestamp. And that's it. There is just one edge case that I remember, which was you can have like a target, like what happens if you have like, if the list is, I don't know, like 10 and 20, and in the input they ask you like, give me the get method for I don't know, the key, the corresponding key to this one is this one. For this key and the value 5, you're gonna say like 5 is not, there is nothing to the left of 5, so this implies that you're gonna return empty, right? And with this logic that we have here, we are gonna move this one is always gonna be true, because the value, the timestamp is gonna be always greater or equal to the value. No, we're gonna always do this one, the else, so we're gonna always move left. No, we are always gonna move right, and then it implies that we're gonna return the first element. No, we're gonna return actually the last element, because it's gonna be L minus 1. So it's gonna be minus 1. So if this is negative, we have to say if L minus 1, we're gonna do this if it's positive, so it means that this is greater than 0. Otherwise, we're gonna return this. Okay, there is an error. I think this. And there is a wrong answer. Okay, I think I did something suspicious with the logic. Okay, if the value, which is gonna be this one, and we're gonna have a target, I think it's just the other way around. Although I've probably... No, wait. Is if the value is less than timestamp. No, timestamp less than value. I don't know why did I tripped. Alright, and that was it for today.